Okay, so this is our last new topic, 3D problems. So it's taking our trig one step further and starting to talk about three-dimensional problems. Now, there's a cool trick that happens when we have a box-like shape, and we're going in that box-like shape, we're going from one corner across the box to the other. We can use the following formula to figure out the length of x. X will be equal to a squared plus b squared plus c squared. Now, what is a, b, and c? Well, a will be the length of the front, b will be the length of the bottom, and c will be the left. So this would be a, this would be b, and this would be c. So we can use this expanded Pythagorean theorem to find the length of the dark arrow. So it only happens when we have these box-like shapes. So if we put this in to the formula, we get 9 plus 16 plus 36, which equals root 61 and will be 7.8. And it's in centimeters, right? Because the original is in centimeters as well. So we can do that with the following. It's pretty straightforward. We just substitute it in. So if I'm going to try this one here, it's going to be x will be square root of 5 squared plus 7 squared plus 6 squared. Okay, now what you can note is at the bottom it's got work area for all of these. So this is the first one, 5 squared plus 7 squared plus 6 squared. So we take those three measurements and we just put them in for a, b, and c. We'll get square root of 110, which becomes 10.5, and they're in, meters, not centimeters, sorry. I did centimeters for the last one, so it was in my brain. Okay, so take a moment, try 2, try 3, try 4, try 5, and you can then check and see if you got them right. So you might want to pause, try them, and then go take a look. Okay, we'll assume that you tried them. So for 2, x would equal square root 7 squared plus 8 squared plus 10 squared. Those are the three measurements for 2. And we get square root of 213 is equal to 14.6 centimeters. For number 3, 5, 9, and 8. And the neat thing is that it doesn't matter what order they're in. Because you're adding, you can put them in any order. You could have 8 squared plus 9 squared plus 5 squared. You're still going to get the same thing. Regardless of the order, you'll get square root of 170, which is 13.0. And in here, it's millimeters. Okay? So let's move it up a bit. And we'll do number 4. So number 4, we have 6, 15, and 2. And again, doesn't matter the order. We can go 6 squared plus 15 squared plus 2 squared, and we'll get square root of 265, which is equal to 16.3 centimeters. And then our last one, 0.5, 3, and 2. Again, it doesn't matter the order you put them in. I'm going to put them in the order from left to right. So 0.5, I'm going to put it in brackets just because it's the decimal, plus 3 squared plus 2 squared. You have to square them each independently. You're going to get 13.25, which gives you 3.6, and it's measured in meters. Okay, so this is the expanded Pythagorean theorem. So it's kind of like a little trick. Now the next problem, hopefully I can kind of explain it so that you can understand what I'm talking about. But it's really actually just talking about a scenario where you might use this and it's with an airplane. So let's look. Okay, so here's an airplane scenario. We have an airplane taking off from this point here, the blue point. It wants to go to this point here. So if there was no wind, if it took off, it would just go straight up this blue trajectory. If it didn't take off and it still wanted to go, it would go flat on the ground, this trajectory. But because there's a wind, what happens is the wind pushes it and it goes off to here. So we have wind shear. So the trajectory changes. Now, when we look at this, we have a number of triangles make up the sides. We have the front and back, which are the same triangles. They're the same shapes. And we have the top and the bottom, which are also the same shaped triangle. This shape is used to represent an airplane's climb from takeoff. Its path is affected by winds which change the airplane's course. So basically the plane wants to go straight, but the wind pushes it over to the side. Okay, and we get this unique prism shape. So if it would stay on the ground, it would follow the shape of W, right? Hopefully you can see that yellow. If it, with no wind, it would take off and it would follow the path of Y, okay? But if there's a wind from the south, after takeoff, it's going to push it and it's going to follow that path Z. So you can see we've got Z, we've got Y, and we have W. Okay, there's also another path in there which is X. That's if it stayed on the ground and the wind was strong enough that it could push it over to the side. Okay, but it actually probably, if it's not off the ground, it's not, the wind is not going to be able to do it. So the actual path of the plane is Z. It's the actual path and speed of the plane. Okay, so we want to know what that trajectory is. It says on the diagram, shade in the triangle at the back of this object that has a Z as its hypotenuse. So the object that has a Z as its hypotenuse is this triangle at the back here. Okay, it's the back of this prism. Now the interesting thing, it's exactly the same size as the one at the front. So it's the same size as the one at the front, is just been pushed to the back. Okay, now to calculate the measure of Z, first we're going to find X. Okay, now X is on the bottom. Alrighty, so we're going to find that letter X back there. We have to find that X and then X becomes the bottom of the triangle that has Z. Oh, this is crazy. Okay, let's see what's going on here. So let's take a look. We've got, I'm looking at my notes here. We'll go to the next page. If we're looking at this, we now have one with measurements. If this was a prism that, like the boxes we did in the first case, we would have a square here. We would have a square prism there, right? So like the ones at the beginning. And what we're basically doing is we're drawing a line from one corner at the back to one corner at the front. So we have a dotted line there, okay? Sorry, it's not straight. I'm going to try and see if I can make it straighter. There we go. Oops, I erased my blacks. I'm going to try it again. Take out my dots. Okay, don't want to take the black. Okay, so that's exactly what we were finding before. Now looking at this, we have our 3 from here, our 8 from here, and our 10 from here. And what we're looking for is we're looking for that angled Z. Now the bottom triangle is 8 by 10. Okay, so that's the bottom triangle that we're looking at right in here. So let's color that in. So that's this triangle here. Okay, that matches up with this one. Okay, and you'll notice that it has an X there. Okay. And we want to know what X is. So looking at that, we can use our Pythagorean theorem, and we get x squared is equal to 8x plus 10x. So it's equal to 164. And then to find x, we take the square root of 164. We're just using the Pythagorean here, and we get 128. Okay. Now, the back triangle, which is going to give us our z, if we label it, we have, we have our 3 here. We're going to have our right angle in like that. And we have down below, we have what we just found out because we have our x. Sorry, I forgot a decimal here. 12.8. Whew, makes a big difference. So we would have our x, which we just figured out, which is 12.8. And we're going to use this Pythagorean theorem to figure out our z. Our z is this length. So what we're looking for there, if we shade it in, we're looking now at the back triangle. Okay. So that's equivalent to this triangle here. Okay. This is a weird problem. So here, our x squared is 12.8 squared plus 3 squared, which is 172.84. And z is going to equal the square root of 172.84, which equals 13.1 kilometers. Now, here's the thing. That whole thing we did on the previous page, where we took our 3 numbers and we added them up, we're going to check that and see if we get the same number. So if I take, instead of doing all this, oh, I got to find this triangle and then I got to find this triangle, if we just say, oh, we're looking for that one, so we're going to take the 3 measurements from up here, the 3, 8, and the 10. So 3 squared plus 8 squared plus 10 squared, what we get is the square root of 173, which is really close to 172.84. And when we talk about decimal places, we get 13.1 kilometers. So instead of doing all that work with the triangles, which you all said, ooh, yuck, I don't want to do that. We don't have to. We can just use that expanded Pythagorean formula to find that line. So this means that the plane traveled 13.1 kilometers after takeoff to reach an altitude of 3 kilometers. Okay, so save yourself some work. Use the expanded Pythagorean theorem to find those 3D problems. Now, this next question says, after leaving the airport, what was the angle of elevation of the plane's path? Well, let's think about what we know. We know this is 3 because it went up 3. We just spent all that time finding z, right, which is 13.1. And what we want to know is we want to know the angle of elevation. So we want to know what that angle is. So now we can use our trig. So let's label. From this angle of interest, we have our opposite and our hypotenuse. So use the same rules. We've labeled. Now we're gonna circle, and opposite and hypotenuse tells us that we want to use sine. So sine is equal to opposite over hypotenuse, which is equal to 3 over 13.1. sine theta says that. So theta will equal sine -1 of 3 divided by 13.1 is 0.229. So theta is equal to 13.2 degrees. So that's our angle of elevation in there. And basically that triangle there is the same as the, oops, don't want that one. It's the same as, sorry, the red triangle in the back at the original question, okay? So that's the question that's what we're looking at up there, okay? Because that tells us the height and it tells us the hypotenuse, okay? Now, for this next one, it says try this one. Are you gonna do all those work with triangles? Well, you don't have to. You can just use your 12 kilometers, your 7 kilometers, and your 4 kilometers, and we want to find that side that we're looking for. We want to find the angle of elevation. We're not actually looking for x. We are looking for that z up there, right? So finding that z, we're going to go, because it's going to have, we're going to use that expanded Pythagorean formula. So z squared is going to equal the square root of 12 squared plus 7 squared plus 4 squared. So it's going to equal, if we put this in our calculator, let's figure it out. 12 squared plus 7 squared plus 4 squared. I like my calculator to do my work for me. We'll get 209. I take the square root of 209 and I get 14.46. Now I want to find the angle of elevation. So from this, I know that it goes up 4, right? I've just found z. So this is 4 here. It's my right angle. This is 14.46. And the angle of elevation is going to be this angle right in here. So I know my opposite and my hypotenuse. So sine of theta is equal to opposite over hypotenuse, which is equal to 4 over 14.46. I think I actually put an extra piece of paper in just to do the work here, but I think I can fit it in. So theta is equal to sine -1 of 4 over 14.6, which is equal to, let me figure that out. And I get 16.1 degrees for my angle in that triangle. Okay. So when you see these 3D ones, I'm mostly looking for this expanded formula. And it gives us that, that new path for that plane. Okay. Just keep your eye out for that. And those are the kind of problems that you're going to do looking at these. Find the z. Don't worry about finding the x and then the z. Use your expanded Pythagorean, okay? It wants you to find x. You could do that. You could take your Pythagorean and find x. I'll be happy if you just find z and the angle of